All right, y'all. Welcome to the stoichiometry homework packets. It's officially arrived. As we start this unit, just remember there is a method to our madness. The reason we're asking you to do things in certain ways, including boxing in your given and circling your unknown. By the time we get to pages 5 and 6, this becomes quite a process. So make sure you're keeping up with what your teachers are expecting from you. Otherwise, it'll get difficult. Okay, for everything in this class that requires math, we're looking at you have to show your work. Without work, you're not getting credits. So make sure you're copying this work down along with us. Okay, this unit, problems tend to come in groups like this. Use this equation for problems 4 through 7. So it says 2 aluminum oxides plus 6 fluorine yields 4 aluminum fluoride plus 3 oxygens. That's an already balanced chemical equation for you. Our coefficients out front are used as molar ratios, so we can use that like a recipe. Got 2 cups of this plus 6 cups of this. We'll make 4 dozen and 3 extra. Okay, so we're going to use those as we get into the problem. Now, I'm going to start my problem by boxing and circling. And in this case, it says how many moles of oxygen. When I circle my unknown, I circle the unit and the compound, because we're changing both this time. We'll be changing the unit and the compound. So that's both my given. Will be made if 0.35 moles of aluminum oxide is reacted. That whole thing is my given. So you need a number, and my pen is not awake yet. I need a number, a unit, and a compound. Okay, you need all of those in your given. And then we do dimensional analysis. Okay, and I'm going to start over here to the left so I have room if the problem goes on. Whatever I boxed in, just like we did in our dimensional analysis unit, 0.35 mole of aluminum oxide. So I can come up here and say, of my 1, 2, 3, 4 things, which one is aluminum oxide? That one. So I don't have to rewrite the formula. But yes, 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 you do have to write that in the problem, because we're changing compounds. Okay? So once my given is there, I disco down my units. So I'm going to switch to pencil here. And I'm going to disco down this whole thing as my unit. Moles of aluminum oxide. And I'm looking for moles of oxygen. So that's what goes on top. Moles of, and it says up here, O2 is oxygen. It's diatomic, one of those Brinkelhoffs, like that. Okay? So I am allowed to do this. I'm allowed to change compounds, have different oxygen over aluminum oxide, as long as I am in moles over moles, which I am. So that's okay. Now, a mole always gets a 1 in front of it. We learned last unit. This unit we're saying unless it's mole over mole. So when I have mole over mole and I'm changing compounds, I need the mole ratio, which are my coefficients. So I'm going to use these guys up front. So in front of mole oxygen, I'm going to use the 3 right there. And on bottom where I have moles of Al2O3, I have a 2 there. Okay? So I'm going to say the top number is multiplied and the bottom number divided, just like we had been doing. Let me grab this, wake her up. 0.35 times 3 equals divided by 2 equals. So my answer is going to be 0.525, and it also reminds me to do with units. Okay, so moles of Al2O3 is on top and bottom, which means I multiply and divide. So effectively, that cancels out, and it leaves me this as my unit. The whole thing, not just mole, but moles of oxygen. Okay. For number 7, we're going to start by boxing and circling. If you react, so here's a number, 2.30 moles of fluorine. There's my number, unit, and compound, that whole thing. How many moles of oxygen would be produced? Okay. So I start with my dimensional chart. In my entire given, 2.30 moles of fluorine, and I always want to check up here because sure enough, if fluorine is F2, and that will make a big difference later on in our homework packet. Okay, so I'm going to put F2 for fluorine, and then I just go down this whole thing. Put mole, F2, and I'm looking for moles of oxygen, which is O2. So mole, O2. Now, a mole always gets a 1 in front of it, except this is mole over mole, which means I need the coefficients. So for oxygen, it's 3. Put that down here. And for fluorine, it's 6. That's my ratio, my ratio in the recipe. That was tricky. Okay. Multiply our top numbers. 2.3 times 3 divided by 6 gets me 1.15. And it reminds me that the whole point of what I'm doing is changing units and compounds, so my answer has to have my unit and compound. Okay? Mole F2 is on top and bottom, so it disappears. Mole O2, again, is my unit. Mole O2. It's alright if you spill out of that box a little bit. Okay. Again, there is a method to this madness. This is going to make a huge difference as we add a step before and after this. So don't try and take any shortcuts on pages 1 and 2. We're trying to get you used to this process. Okay, let's take a look. 8 through 10, we've got this equation. Basically, it's the decomposition of iron 3 oxide. So 2 iron 3 oxides decompose into 4 iron and 3 oxygen. Let's look at number 10. A student collected number unit compounds, so 0.75 moles of oxygen. That whole thing is my given. And it's asking me to solve for how many moles of iron were also collected. Okay. Come back here. 0.75 mole. And I check my guy. Oxygen is O2. Okay, I take my entire unit, any letters I wrote, and bring them down. Mole O2. And it's asking me for moles of iron. So if I look up here, it's not Fe little 2. Iron is not one of those diatomics, so I can just say mole Fe. And again, once we add the mass step into this later this week, that's going to be relevant. That's going to make a difference. Okay, it's mole over mole, so I use coefficients. So 2, 4, 3. Those are the numbers we're looking at plugging in. For iron, I'm going to put in the 4. And for oxygen, we put in that coefficient 3 right there. Multiply, divide. So 0.75 times the top divided by the bottom. Oops, and you know what? I totally did that wrong. 0.75 times 4 divided by 3. No, I did not. Look at that. Exactly 1. So I will get 1 mole of iron for every 0.75 moles of oxygen that I react. Okay. Units. Mole O2 on top cancels out with mole O2 on bottom. So that leaves me with 1 mole of iron. Okay. Hopefully you're following along with the rules and getting into this process today, because it gets worse as the unit goes on. But let's look at balancing. We did balancing Unit 5 this year in 2018-2019. So if you are needing more help on balancing because you're new this semester, or you moved in, or you struggled in Unit 5, or you forgot, okay? I'm just going to do a little bit of review here, but what you should do is go to the YouTube channel, okay? Unit 5, 2018, that's one of the playlists on the YouTube channel. And then there's 2 good videos for help. You can look at homework pages 3 and 4, or the rainbow balancing has been so helpful for some students, that colorful method. Otherwise, I'm going to show you kind of that ping-pong method that we learned in class. So I'm going to divide my reaction in half, my reactants from the products, and write down what I have. Right? I've got lithium and bromine on each side. I write them down in the same order. And then I write down how many I have. I've got 1 lithium here and Br2, so 2 bromines, and then 1 lithium and 1 bromine. So we start from the top and work our way down. On top, lithiums are already balanced, 1 and 1. So I work my way down. Bromines are not balanced, so I go to the smaller side, which is this side. And I need to multiply it so it matches the bigger side. So 1 times 2 equals 2. And then that's the number I'm going to put here in front of bromine. Now I have to be careful because that doubles my bromine, but it also doubles my lithium. So now I have 2 lithium on that side. I had to. In order to get more bromine, you have to get more lithium, which means I go back to the top, and it's not balanced, so I go to the small side, which is the left side this time. Times 2 equals 2. So I take the number I multiply by. Okay. Putting a 2 in front of lithium, that's not attached to anything, so that doesn't change anything except lithium. 2 lithium here and 2 lithium there. I've got 2 bromine here already and 2 bromine there. So I'm balanced, and I just put a 1 in the blank. Right down for this one, this is a single replacement reaction. So we cut her in half. Say nickel, oxygen, chlorine. And then I want to write them in the same order over here, even though it's not in the equation. That's fine. Nickel, oxygen, and chlorine. Okay. I have 2 nickel, says 3 oxygen, and 2 chlorine. On this side, I only have 1 nickel. I have 2 oxygen. I have 3 chlorine. Okay. So start at the top. Nickel is not balanced, so I've got 2 and 1, so it's unbalanced. I come over to the small side, and I'm going to multiply this by 2. That gives me 2, so I put this number here. Okay. So that gives me 2 nickel, but it also gives me 6 chlorine, so I need to write that down. I don't know if I want 6 chlorine, but I know I have to have 2 nickel, right? So top is balanced. I work my way down, and I say oxygen 3, O is 2. So some people have done the 1.5. That's worked for them. But for me, whenever I see this, I multiply them together. I can't turn a 2 into a 3 or a 3 into a 2. So we need to make these both 6. So I'm going to multiply this one by 2 and this one by 3. Okay. So I want this problem to be 2 times 3 equals 6. So I have 2 times 3 equals 6. On the left, I need 3 times 2 equals 6. So I put the 2 there. And now my oxygen are balanced, except that unbalances the nickel like a pain in the butt. Now I have 4 nickel. Okay? So I'm going to come over here and just say, great, never mind. Everything we did up at the top is getting erased. And that just happens, people. That's okay. 1 and 3. Okay. Now I want 4 nickel. So I would say times 4 equals 4. Put the 4 there. 4 times 3 down here, that also gives me 12 chlorine. Man. So my nickels are balanced at 4. My oxygens are balanced at 6. My chlorines are not even close to balance. I've got 2 and 12. So I go to the smaller side, and if I want this to equal 12, I multiply it by 6. So I would say 6 chlorine times 2 equals 12. And then we're balanced. 2, 6, 4, 3. Okay. Again, if you need more help, or if this last problem was pretty intense, check out these things. Talk to your teacher. Come in for tutorials, because there's definitely balancing on this upcoming exam. Thanks, y'all.